This is block 3 from topic 3, and it is on page 73 of your workbook. So, today we're going to be looking at some different prices of pizzas. And problem 1 in your book says that each pizza costs $7. So every time I order another pizza, how much more am I going to have to pay?
$7.
$7. Okay, so pretty simple. Let's add to our chart here. So does it make sense that if I'm at order 0 pizzas, I have to pay $0? Okay. That makes sense right now, but we're going, here in a minute, we're going to look at something that I order 0 pizzas and I still have to pay something. Yep, we're gonna blow your mind. So, when I decide I want to order 1 pizza, how much is it going to cost me? $7. And I say, you know what, I'm hungry, I want to order 2 pizzas. It's going to cost me $14. I say, you know what, I want leftovers. I'm going to go ahead and order 3 pizzas. I'm at 21. And if I decided to order a friend a pizza too, 4 pizzas gives me $28. Okay, so I want to take a look at the process because that's what helps me create an equation or algebraic rule. So my process here, I'm seeing that this 7 is getting repeated based on how many pizzas I order. So it's repeated addition, which repeated addition is just multiplication. So go ahead and jot the process down so we can use that to help us write the equation or algebraic rule. So when creating my algebraic rule, what would I probably consider this column? What letter? X. And my cost in dollars would be Y. Well, what is happening to the number of pizzas each time? It's getting multiplied by 7. So when creating my algebraic rule, I'm going to first label my number of pizzas. Is changing, so it needs a variable. We're going to call it X. 7 is being multiplied every time. So I'm going to multiply my variable of 7. Cost in dollars is my Y. Does order matter in multiplication?
No.
That is 7 times 1 and 1 times 7 the same thing. That is why I'm able to flip-flop this 7 and X to the way I like to see it, because order does not matter. What other operation does not matter? Addition. So I could flip-flop anything with addition or multiplication. So my equation or algebraic rule would be Y equals 7X. I believe that answers question 1B. We now need to graph this. And I know typically we would probably label our y-axis with what numbers? What numbers would you want to use? You would want to count by 7s typically. I want you on this one to count by 5s. Just because we're going to be comparing graphs to another graph. So I want you to purposefully count by 5s, even though we typically would count by 7s. So I have 3 representations here of this scenario. I have it in a table, algebraic rule, and a graph. am I able to tell from all three representations, do all three show you the price of one pizza? Where does it show you that on a table? The one, our magic number 1 is telling me cost of one pizza. Where is that telling me a cost of one pizza in my equation?
The coefficient.
The coefficient, which is my unit rate or constant of proportionality. And where in the graph can I see it?
The one.
Well, magic number 1. Okay, so all three. So what is my constant of proportionality? 7. Lost my train of thought there. Good talk. Oh! You said the constant of proportionality is 7. So does that mean that this graph is proportional?
Yes.
What are the two criteria for proportional? Straight line and goes through the origin. Does it meet those two factors?
Yes.
Well, if it has a constant of proportionality, obviously it has to be proportional, because that's kind of key terms there. Okay, so we have some questions below that we need to answer. It says, using the algebraic rule you wrote, calculate how much it would cost for 10 pizzas. So if I needed 10 pizzas, what is my algebraic rule? It is y equals 7 times x. We're plugging a 10 in for x because, whoa, maybe I ought to plug it in. X represents the number of pizzas, so how much is it going to cost? $70. B says, if you have exactly $84 to spend, how many pizzas can you buy? 12. How do you get 12? 84 divided by 7. And where did you get 7? Cost per pizza. So 84 divided by 7 gives you 12. So you know there should be 12 pizzas. And C kind of sounds silly, but it's meaningful here in a little bit. It says, what if you buy 0 pizzas? How much would it cost you? How much is it going to cost me?
$0.
$0. Does that make sense in the problem?
Yes.
Do you expect to pay $0 if you bought 0 pizzas?
Yes.
That does make sense. Okay, so we're going to flip over to problem 3 on the back side of that page. Shh. Tracking all your noises. So this problem says cheese pizza costs $7 each. Anything different so far between the two problems? No. And then it says there is a one-time charge of $5 to have your pizza delivered. So, if I ordered 10 pizzas, do I have to pay 10 sets of $5? No, it says it's a one-time fee. I would have to pay 10 sets of what? $7, which is my cost of the pizza. Minus 2. Crazy.
Why minus 2?
Right. So, I need to create my chart. And I'm looking at this variety of pizzas here. 1, 2, 3, and 4. And I've already calculated the cost. One pizza is going to cost $12. 2 pizzas, $19. But I'm going to change that. I see 7 gets repeated several times. So I'm going to change that to multiplication. Is the 5 getting repeated in one problem? No, it's just being added every time. The 7 is getting repeated. So copy that down. 3 pizzas, you're at $26. 4 pizzas, $33. What did the 5 stand for? Delivery fee, the one-time delivery fee. 7 was price per pizza. Alright, so we need to establish an algebraic rule. So what am I going to title this first column, number of pizzas? What letter? X. Cost in dollars, we'll call it Y. What number did we say is getting repeated and multiplied? 7 is getting repeated. Number of pizzas here is being multiplied by that 7. The 5 is doing what in the every time? It's being added. So I'm going to, again, in my algebraic expression, I'm going to add the 5 one time. My number of pizzas changed, so I'm going to call that X. That times 7 stays the same. And we already established order does not matter in multiplication, so I'm going to flop that X and 7 to the way I like to see it. Y equals 5 plus 7x. Could I have that algebraic rule written a different way?
Yes.
How?
7.
What you got?
Y equals 7x plus 5.
Y equals 7x plus 5. Why is that equivalent? Why is that the same?
Because it doesn't matter what order you add.
Order does not matter in addition. Very good. Okay, so for 3b, we now know our equation, our algebraic rule, y equals 5 plus 7x. Now we want to graph this, and we're going to use those same 5, 10, 15 on my y-axis, and we're going to look and see how the graph turned out. So graph yours. So I have 3 representations here. Looking at the graph, can I say that this situation is proportional?
No. No.
Okay, what is the 2 questions I had to ask myself? Is it a straight line?
And it's at the origin of 0.
Okay, did it go through the origin?
No.
No. So this is an example of a non-proportional situation. It did not go through the origin. Right, fellas?
Yes.
So, we want to, on problem 5, compare these two. So looking at problem 5, it says, how are the pizza situations similar and how are they different? So raise your hand if you have a similar. How are they similar? What? Oh, I'm sorry. Let's go to number 4. Let's look at, I skipped 4. Number 4D says, how much would it cost to buy 10 pizzas and have it delivered? So,
5.
we go to a blank page. So, it's useful. I could sit here and continue my table on till I get to 10. I could continue my graph on till I got till 10. But the reason we like algebraic rules is because is there any extra work that I have to do? No. All I have to do is plug in a 10. So y equals 5 plus 7x is my equation. So 7 times 10. So what does y equal? $75. So for 4D, it would cost us $75, which then answers our question for E. If you have exactly $75 to spend, how many pizzas could you order? 10. I think they made a little goof there. F says, what if you buy 0 pizzas? How much would it cost?
0.
Looking at my graph, where X is 0, where is it hitting? 5. So me getting on the phone, the first question they ask as a pizza company, they ask first for my phone number, and that tells me what account they're charging to. Second, pickup or delivery. Soon as they hit that delivery button, how much is getting charged? $5. Then I start ordering my pizzas. So as soon as I say the word delivery, they're charging because it's going to cost them to drive to my house. So if I say delivery and I say, you know what, I don't want any pizza. Well, they just sent somebody to my house.
That's creepy.
Yes.
That's
How do they
Yep. So they're going to charge somebody $5
just for calling them?
just for calling.
That's nasty.
All right. We're going to talk more about that in a second. It's detecting all the talking. So, on 5A, it asks, what is similar in the situations? What do you have similar?
One pizza equals $7.
In both situations, each pizza was $7. So they each cost $7 per pizza. What is different then?
One's proportional and one
Okay, just the whole situation, the pizza situation, what was different?
One was cheese and one
Wow.
Just like
Yes.
one of them added $5 for the delivery.
One of them had a delivery charge and the other one did not. The next question wants us just to focus on the tables. So, let me get to the right problem. If I'm looking just at the tables, what is similar in the tables?
They both multiply 7 by something.
They're both, but that's kind of in the equation that we figured out. I want the X and Y columns. What is similar? Close.
The X's were going by ones.
The X's were going by ones, okay?
Both of them are a straight line.
I don't know that based on the table yet. I know that based on a graph. What?
The unit rate is $7.
What is happening every time in this Y column to go to the next Y value?
Multiplied by 7.
It's going up 7 every time. What's happening here?
It's going by 7.
It's going up by 7. So both Y columns are increasing by 7. Now what is different between?
The X has $5 more than the Y. I mean, the Y has $5 more.
Okay, I merged both the tables together here. So here's the number of pizzas is my X, then there's two different Y's. One of the Y's he's saying has $5 more than the other one did. One of the Y's started out at 0, one of them started out at 5, and that is our main difference there. One has a cost for 0 pizzas, which kind of stinks. Next, ask about the algebraic rule. So if I'm looking at the rule, what is similar?
The coefficient is 7.
They both have a coefficient of 7. What is different?
There's an additional 5, there's a plus 5,
One of them has a additional charge of plus 5. So they both have a y equals 7x. Different. One has a plus 5 while the other one does not. Okay, now if I'm looking at the graphs, I'm going to merge both graphs together and compare them. What is similar between the graphs? Raynor?
They're both the same straight line.
They're both the same. I like how you said the same straight line. Did you mean the same same?
They're on this, they run this same direction, they run at the same degrees.
Okay, they have the same steepness. Like if I was looking at it at like a mountain, they have the same steepness. What makes them have the same steepness? What mathematically is making them have that same steepness? Huh? The unit rate or
Constant.
our constant or not really constant of proportionality, because one doesn't have a constant of, one's not proportional, but that 7x that they both had in similar, that's what's making them have the same steepness. So what is different about the two? One's not proportional, but why?
One
What-
starts with 12 and then just goes by 7. It had 7 plus 5 and then just kept on going with 7.
Right.
It started at 12.
So Ty?
One of them has a delivery fee.
Okay, and what is telling you that? Yes, sir?
One starts at the origin.
One starts at the origin, and one is starting at the delivery fee of 5. So the similar, they both are linear, and what did linear mean? Straight line, and they are equal steep. They're equally steep. Then different, one passes through the origin while the other does not. Now the last question. What values make sense as inputs for the algebraic rules if you allow only numbers that make sense in the context of the situation? So the context of the situation means dealing with ordering pizzas. So basically, can I call Pizza Hut and say I want to order 3/8 of a pizza? How do I order pizzas? I order them as a whole pizza. So you're telling me I can't order fractional parts of a pizza, which means I can't order decimal parts of a pizza. Can I order negative pizzas?
No.
That wouldn't make sense in the problem. So what type of numbers am I ordering pizzas? Whole numbers. Well, with pizzas without delivery, did it make sense to have 0? With the out delivery, did it make sense to pay $0 if I ordered 0 pizzas? That made sense? So pizzas without delivery, 0 or more in whole numbers would make sense. But pizzas with delivery, did it make sense to order 0 pizzas and pay $5?
Bananas.
That was bananas. Okay? So, what should we probably start with on pizzas with delivery charge? So, if I heard a 5 or more. Can I not order 2 and it still makes sense? What number should I here it made sense that $0 ordered 0 and paid 0. What should I start how many pizzas should I start with with delivery charge? 1 or more, because the 0 did not make sense. So 1 or more, but as whole numbers. All right, we're gonna next take 2 sticky notes. The proportional sticky note, we looked at 2 problems. One was proportional and one was non-proportional. Problem 1 and 3. Which one was an example of proportional? Problem 1 or 3? Problem 1. So we're going to want to put the proportional sticky note over problem 1. And where should I probably put the example of a non-proportional? Problem 3. So notice here on non-proportional where it says when x equals 0, then y equals, that's not a hashtag. What is that standing for?
Number.
A number. So copy these, put them in your book. You'll have problems 1 and 6. Oh, I'm sorry. 6 through 7 for homework. Thanks for listening. Like, subscribe, and hit that notification bell.
Bye.
Problem 6 and 7 are referring back to problem 1 and 2. So be sure to reference back to those 2.